Hey math fans, we're on section 1.3.2. Let's get started. If a pendulum swings to 90% of its previous height on each swing and starts out at a height of 60 centimeters, what is the equation that models the scenario? What is the graph? The first thing I recognize is the 90%. Whenever there's a percent or a rate or doubled, triple, I know it's exponential. So let's start off with the exponential equation. Y equals A times B to the X. The starting height is 60 centimeters, so that's going to go in for my initial value of A. Now the 90%, because it's the actual rate and it's not an increase, it is not a decrease of 90%, it's going to be 90% of the initial value. I don't need the 1. In other words, if I wanted to use the 1, I could write it as 1 minus 10% because it's losing 10% of its height every time for a total of 90%. So there, you could write it as 1 minus 10%, or you could write it just as 90%. And I'm going to leave it at 90%. Next, you guessed it, we make a table. So we always start off with the intercept, which is going to be 0. And remember, anything to the 0 power, when I plug 0 in for x, is going to be 1. 0.9 raised to the 0 power is 1. 1 times 60 is 60. So I'm going to get 60 out. So I'm going to put a dot at 0, 60. That's going to be our starting point, 60 centimeters. As we continue in the table, you see that 1 is going to be 54 centimeters, so it's losing a little bit of height, and then 2 is going to be 48.6. That might be difficult to graph here, but when you start to see the change, it's probably a little bit later on, and let me show you. What you're going to notice when you start graphing this is that it starts to look like a straight line, but in actuality, when you start getting to the bigger numbers, it starts to look like a straight line in the beginning, but then it's going to start to do a curve. And as the x values get larger, the y values will start to approach 0. And here's a nice looking graph that the book has. And so we were kind of close. And as you can see, it starts off in the beginning. It starts off, it looks like it's going down in a straight line in this section, but it actually starts to curve as x gets larger. The bacteria Streptococcus lactis doubles every 26 minutes in milk. If a container of milk has 4 bacteria in it to start, write an equation that models this scenario and then graph the equation. Our starting point again is going to be 4. 4 is going to go in for A. And it says it's going to double every 26 minutes. So I'm going to put a 2 in there for doubling. And then it's going to be every 26 minutes. So if I put x here, and x stands for the number of minutes, I need to divide that by 26. I'm going to raise this to the x over 26 power. And then what am I going to do? You guessed it, we're going to make a table. Obviously, we start with 0. Anything raised to the 0 power is going to be 1. 1 times 4 is 4, so that's going to be our starting point. Now, I'm not going to plug in 1, 2, 3, 4, because it's going to be a crazy amount of work on my calculator. I know this thing is doubling every 26 minutes, so I'm going to go up in multiples of 26. If I plug 26 up here, 26 divided by 26 is going to be 1. 2 to the 1 power is 2. 2 times 2, or 2 to the 1 power is 2. 2 times 4 is 8. And it'll be a nice even number. If I start going up by 1, 2, 3, 4, it's going to be crazy fractions and decimals. And let's just go up every 26 minutes. And here's the rest of the table. And as you can see, it's getting bigger pretty quickly here. And so what we're going to do is we're going to create our graph, and we want to make sure that all of the x and all of the y's can be graphed. So let's try and fill in some of the axes here. So I chose to go up kind of every 4 by 10. You can choose a different scale if you want, but let's try and graph some of these. And here are my first 3 points, 0, 4, 26, 8, and then 52, 16. Now we're going to jump to 78, and now we're all the way up to 32. So this thing is really starting to take off now. Notice how there's a definite curve to an exponential. It looks like it's a straight line in the beginning, but then it's just going to take off. And then finally 104 is going to go all the way up to 64, which is kind of off the grid, and I don't know how good I'm going to do it drawing this. There it goes. And it's really starting to take off there. And so there's the graph for this particular problem. And there's the official book's answer. Again, notice it's not too much is happening in the very beginning in this section. Some people will accidentally draw a straight line. It's curving a little bit, but you'll notice as x gets larger, it really starts to take off. And finally, the most dreaded out of all of the exponential equations, it's the compounded interest problem. So let me read the problem for you. Example 3 says an investment of $500 is compounded monthly at an annual rate of 3%. What is the equation that models the value of the investment? Graph the equation both on the calculator and on graph paper. On the exam, I'm going to be giving you this formula, so you don't need to memorize it. What I do need you to be able to do is understand what each of these letters, these variables mean, okay? So this A still, we usually call it Y, and I have no problem if you want to call it Y, but it's still going to stand for how much money or how much stuff or things are you going to have at the end of this time period. Instead of calling the initial amount A, they call it P here for the vocabulary term principal, which is your initial amount when you start your investment. And so that is that 500, your starting point. It's going to be 500 goes there. And there's that infamous 1. You always have to have that 1 in there. You don't want to lose all your money. Now, this is where it gets a little bit tricky. The R is pretty self-explanatory. That's going to be your 3%. So I'm going to write 0.03 right there. But N's going to stand for the time period. Okay, so if it is biannually, in other words, twice a year, 2 is going to go in there. Now, this is happening monthly, and you got to think to yourself, how many months are there in a year? And the answer is 12. So in this particular problem, N is going to be equal to 12. If it says quarterly, N would be equal to 4, because it's happening 4 times a year. There's 4 quarters in a year. So monthly is 12, quarterly is 4, biannually or twice a year would be 2. And then if it's just annually, you don't have to have use this formula at all. So let's put 12 in here. And then you got to put 12 there. And then we're just going to leave T. So let's simplify all this. So Y is equal to 500. And then let's use our calculator. And you get 1.0025. Please do this. Simplify this part, and it'll make it so much easier when you're making your table. Because that's right. What are you going to do next? You're going to make a table, and you're going to really need to rely on a calculator to make these calculations. More specifically, a scientific calculator that can start doing exponents for you. So start off by plugging in 0. I would say let's jump to like 5 or 10 or 20 or something like that, just to see how quickly this thing is going to take off, and then we're going to graph it exactly the same way. Just to check your work, I want you guys to be able to use Desmos to check your work as well. So after messing around with some of the settings here, I can finally see the curve, because in the very beginning, not much is happening. Okay, here again, when x is equal to 5, x is equal to 10, it looks kind of just like a straight line. But boy, when x starts to be equal to 40, 50, look how much it starts to take off. So this is definitely a compound. These compound interest problems are definitely exponential. And again, your graph is going to eventually look something like this. Let's take a look at some homework problems. So this is question number 9 from your homework. It says write an equation to model growth or decay in the following scenario. An investment earns $600, 2.9% interest, and it's compounded quarterly. Let X represent the number of years, and then Y is going to be the investment worth in dollars. So let's write the formula first. So there's the compound interest formula. Remember, P is going to stand for the principal, which means the initial amount, which is going to be $600. And then it'll be 1 plus, and this is 2.9%. Be careful here. 2.9% is really 0.029 over, and then is compounded quarterly. Quarterly, it means 4 times a year. And we got to put that 4 up there too with the times t. So using my calculator, I went ahead and simplified, and I'm going to check my answer here. Y equals 600 times 1.00725, and then raised to the 4. I'm putting X instead of T. Let's see if we got that. All right, we got that. So now we need to choose which one of these graphs is correct. And so first thing I always look for is it's got to be going through the y-intercept, which is always going to be, if we raise this to the 0 power, it's going to be 1. It should be starting at 600. All of these graphs look like they're starting at 600. So what I need to do is figure out which of these graphs. I need to pick a point here. Like right here it says 18. If I plug 18 on this graph, I should be getting 1,000. But on this graph, if I plug in 18, I'm going to be getting over 1,100. So I guess my question is, I got to ask myself, what is the value of y going to be when x is equal to a certain number? So I'm going to go ahead and try 18 and see what I get. So when I plug in 18, my calculator gave me 1,009.334. So now it's just a matter of where can I find it going through 1,009. And right here, that could be 1,009 right there. It could be. I don't know. I'm gonna put this as a definite possibility. This one's out. This one's too large. At 18 right here, this is well above 1,000. So this one's not correct. Let's scroll down. This one for 18, let's see what this one is. Yeah, 1,009 is way up there, so this one's wrong. And 18, 1,009, this one's wrong, so my answer should be A. So you just have to pick a point for X, and I would say, make it be probably further away from 0. I wouldn't pick 2 or 4 because usually the big changes don't happen until X starts to become really large or really small. So I'm going to go ahead and choose A. Let's hope I'm right. Did we get it? Yeah, we got it. All right. So there's a typical problem from your homework, and I will help you during class. And on that note, I'll see you in class. Good luck, you guys.